Welcome. If you didn't get a chance, you missed out. Oh my goodness, it was amazing. I got one earlier, amazing massage. So that is Little Jasmine Therapies and Spa. So do check it out. I think it's just down the road, isn't it? So nice and easy to get to if you're local. But yeah, check them out. Perfect. Oh, we've already started. Oh, fantastic. There was me doing a filler. Hi everyone, and hi everyone online. Welcome to BrightonPy. If you have never been before, I'm so pleased you're here. Thank you for turning up. It's absolutely fantastic. We are a group that meet about 3 or 4 times a year, and we just like to talk Python in all its wonderful diversity and awesomeness. And every time we have speakers, I'm always blown away about what that little code that I kind of spend all my day shouting at, what awesome stuff that it can do in other industries. So it's always really, really amazing. But just before we begin, some housekeeping, some hosts. That's me. I'm Laura. Nice to meet you. We've got Sophie down at the back there, who you all should have met when you came in. We have got a lovely speaker, Craig. If you can just hold your questions kind of to the appropriate time, no heckling and things, because, you know, respect and stuff. We do have a Slack channel, and we do have a hashtag and all the cool things that the young kids do. So if you want to take a photo and whack it up on BrightonPy and kind of tag us, that would be lovely. We'd really like that, and we'd share that around. You kind of know what's going on. We always do drinks at the pub as well afterwards, so you're very welcome to join us and carry the conversation. For those of you that don't know, we work for a company called Datacove, and we are a data and analytics consultancy. Mostly everyone else in my company uses R, but I'm the Python person, so yeah. So I will big up the Python, hence why I'm running this. But we do customer analytics, marketing analytics, process automation, and things like that. So if you're interested, come and talk to us about that. We also run quite a few meetups. So you'll notice they're all R, but this is the one that we do. This is our BrightonPy, but we run all of these ones as well in R. So if you are that way inclined or interested, or if you've other people in around the country, share that with them. That'd be quite cool. We'd like to give obviously a massive and special thank you to Silicon Brighton and the Eagle Labs, because without them, this would not be happening. So first of all, Grace or Cameron? Grace? Cameron, would you like to say a little thing? Thank you very much. So Cameron is here for Silicon Brighton.
Hello. I thought it was going to be Andy, but this is a treat. Is it an Andy? Is it Andy first? Let's have a look. Oh no, well, yeah, you can take the after one, Andy. So hello everyone, my name's Cameron. I'm from Silicon Brighton. I run the community and events program, and this is we are in the community, and it's an event tonight, so well done me. So yeah, we are a meetup community. We're the hosts of Brighton and Hove's digital tech sector, and we're running a flagship event, Evolve, of which we're talking to all the meetup organizers about how we're going to make it the meetup of all meetups. We're leading on the Datacove lot a little bit. We're really getting their experience about Earl, and they're just offering up fantastic advice along the way. So we're really appreciative to the Pi community in particular, and we're just looking for the best way to represent everyone on the day. You can attend, exhibit, or sponsor via that QR code there, and it's shaping up to be a brilliant day, and we're looking forward to sharing more details about that. So speaking of the other meetup groups, we've got about 40 different meetup groups now, not just BrightonPy. So if there's anything on that lovely tile board that you like the look of, definitely one to jump on. You can find all of our meetups on meetup.com, and a quick Google of Silicon Brighton or typing in the URL will give you meetups on the website as well. We just want to say a huge thank you to our sponsors as well. They continuously fund what we do. So the live streaming aspect, which allows everyone at home to enjoy and get involved in the community as well. You don't have to come through the door to join in our events. A huge thank you to our supporters as well. Same again, wouldn't be able to do what we do without them, so hugely appreciative. They give up their time, their space, their venues, their staff, all to help us host fun, free to go to meetups. So a huge thank you to them. And then finally, one from me. Here's the QR code where you can follow all of our activities. We've got our website, our Slack channel, which I think most people are going to be on by now. You can join in the chats afterwards, look up job board postings. Like, it's truly a brilliant community in person and online. And yeah, we implore you to jump on that. And yeah, we'll see you there. So thank you very much. I think that's you, Laura.
Thank you, Cam. That's lovely. Thank you. And now it should be, oh, Andy, do you want to say anything? Sorry, Craig. Yeah, just sneak up because he has to do, you know, fire and safety and all the boring stuff.
Thank you, Laura. So, guys, welcome to Barclays Eagle Labs. So the housekeeping part, Laura's also mentioned where the toilets are, through the door, down the stairs and to the left. There shouldn't be a fire drill, but if the bell does go off, the Joker pub. Perfect. Just a couple of things about Eagle Labs. So 3 things just to let you know. So we are a business, forgot my word then, bit of a consultancy. We want to help your businesses grow and scale. That is what we do. So if you're looking for funding, so number 1, we have different segments and different programs that you can go on, and we don't charge you for doing it. The other thing that we've got is our academy. Got a banner up there. The academy is a learning platform. So there's loads of information to help and support you. It doesn't matter what stage of the business you are, if it's at ideation stage or you're looking to exit, there is some training within our site to help and support you. The third thing that we've got is our ecosystem. So yeah, I'm here in Brighton. So my ecosystem is Brighton and Hove. We've got 44 sites across the country. So we can make those connections for you and your business, whether here in Brighton or even up to Glasgow. If it is something that you want to know more about, please speak to me. I'm here all night, or email me and we can be in contact. Thank you.
Lovely. Thank you, Andy. Right, without further ado then, I'm going to pass it over and Craig's going to take us through AIs as APIs.
That's it, AI agents and all of that. Thank you. Right. Almost there. Okay, so there's a good repo, which I'm going to be going through. So if you grab the address down here while I'm talking, if you go to this here, you will come to here. There's a direct link, or you can go to the direct link. There's a repo. It's got everything I'm going to be talking about tonight. It's effectively a mini workshop, the repo. Lots of comments in the files. So when you're at home, you can run through it again. So what's the talk about tonight? It's AI as API in everyday Python apps. It's about AI agents. It seems to be all the rage at the moment. At the beginning of the year, I ended up on this site called the AI Agents Landscape, where they have all the different agent systems and platforms that are available. We have 1,037 today, and in January, when I was looking at it, it was about 700. So it grows and grows. So one wonders, why are all these things developing? Well, when we go through the code today, you'll see that actually it's what I call just day-to-day Python with AI inside it. So if you were to do it from scratch, you'd probably end up building some utilities, some classes, and then you probably think, well, other people could benefit from them. Perhaps they could even make money from them. Hence, you see all these different versions. But the main thing tonight, and what's kind of most important to me, is to simplify and demystify AI agents. Because if you're anything like me, when I first came across them, I thought it was something from a different planet that used a different language and different technology. And I also thought that it had to be either fully AI or not at all. And actually, as we'll see tonight, I believe that is not the case. So I've got a repo. that you can download. And I'm going to be working from my Notes MD, and there's the HTML version here, which we've just seen. And I'll explain all of the things as we go through. I don't want it to be code intensive. What I'd really like is for people to see the difference between, shall we say, day-to-day Python and so-called agentic AI. Because it seems now that if one doesn't have AI in one's apps, one's kind of behind the scenes and you're going to die and your business won't survive. And what we're going to see tonight is actually how we can introduce very small bits of AI that seem quite impressive into our app, so we can tell our clients, yes, it involves AI. They may ask for something that has AI in it, and it can look quite impressive, but it's just going to be a few lines of code. And we're going to see that as we go through the workbook. So a little caveat, this is taking place in February 2025. Laura and I, we organized this back in December, and it seems like a lifetime ago. I mean, I had to sort of almost change a lot of different things because lots of things just have emerged. So with that in mind, bear in mind that this talk, might be a bit rough at the edges. It's designed to be kind of informational and educational, and to really understand that it's business as usual as Python developers. If we know Python well, we're in the right space. We're not falling behind. All our Python knowledge comes in very handy. So as I say, we're going to look at the chat completion of API like ChatGPT, but how do we put that into our code? How do we use it? How do we make it agentic, whatever that means? So let's see where the code differs from AI. And what I've done is I've labeled, this is the AI bit. In the big section of code, there's only a tiny bit of AI, but we can have a bit of AI in our everyday apps and really transform our apps into AI versions for our customers, for example. So who am I? I like to say I'm one of us. I'm just a regular Pythonista. I've been coming here. As the quote says, it doesn't get any easier, just different. No matter how many years I'm doing it, still it's a challenge to keep up to date with everything. I was in tech originally around 2000, DBA, Business Information Architect, came back 17 years later. What was really nice about coming back 17 years later is all my SQL books were up to date, whereas everything else wasn't. So I could go back and sort of like that. And it's a wonderful to be able to do that these days. Obviously, there have been some changes, but by and large, the same books of SQL work today as they did in 2000 when I was studying. I'm also currently working on a project on AI-powered knowledge systems, search, RAG, retrieval augmented generation, AI agents. And what I've been doing is just basically making sort of ebooks about them, because I benefited so much from what other people have shared with me that I thought, well, yeah, people are going to have the same questions as Shortcut. And it's not necessarily original information, but it has all the useful links that I found. So it could save people time where to go and what I found helpful. So for our international audience, our online audience, I live in Brighton in the UK. Just in case anybody doesn't know where they are in the audience, we're in Brighton, so like that. And I'm a volunteer coach at Code Bar Brighton. And I just wanted to, yeah, everything's breaking. I just wanted to say that it's a really great experience going there. I mean, it's amazing to help other people. And what I've found is that the next day, some sort of clarity comes to, okay? Great sort of clarity comes by helping somebody else the next day. It's like the universe helps me and sort of my code feels different. And it's also great going to Code Bar because I realize actually how much I know and I take for granted, all these different tools. So it's well worth going now and then if you want to as a coach, or even as a student, even if you know quite a bit of Python, because we're always learning. Well, I'm certainly always learning. And in my spare time, I enjoy working in community kitchens and I do some partner dancing at times. And pride of my life is Leo, little red fox lab that I got about 3 months ago. There he is. And I actually live round here, and there are about 3 red foxes. You can just see it here. I don't know why I always look over there, but you can just see it here. That seems to be mesmerized with him, and they stare at each other across the road, wondering, which species are you? Are you a dog or are you a fox, etc. So my first computer was back in 1979, which was this paper tape reader that span through really quickly, and you could see it's reading each of the bytes. And cut and paste was cut and paste. One of the first things I learned was how to cut the tape, join it up exactly. That was how I did copy and paste in my time. And so that's a little bit about me. So what are AI agents? Well, actually, if you talk what are agents, it can be quite a hard definition. There are many definitions, but I kind of like this one from Anthropic. They're systems that use LLMs to direct their own process, a sense of autonomy, may invoke tools and functions, and have a certain degree of control about how they complete tasks. And Hugging Face says they're programs where LLM outputs control the workflow. So it's not just about using an LLM, but it's transferring the path of our app to AI, which can be a little bit strange for us as Python developers because we're used to kind of knowing exactly what goes on and which route it's going to take. So I've shown you that AI agents landscape. And as I said at the beginning of the year, there are around 700 and it's growing daily. And we will be able to see why, as we work through the repo, we'll be able to see why that's the case. So my aim for us this evening is that we walk away with agents being demystified, simplified, and really seeing it is just Python code, but with API calls to an LLM that produces an output that we do something with. And it literally is just that. Everything else we hear and we see embellishes it and makes it seem possibly more complex. Now, I could be totally wrong, but it seems to be that's the way it is. And I've spent through all the kind of agent tutorials and courses that I've looked at, I've not seen anything that isn't Python in our Python ecosphere. It's always been Python. There's never been something different. It is just traditional Python with API calls. And as I say, the repo is built as a mini workshop. We're going to be switching over to that. And in the notebooks, I've made them actually like slides and sort of workbooks so we can actually see the notes. I don't want us to get into the code and look at every line and explain it. It's late in the evening. We've been doing it all day. It's to get the gist. And if we get the essence of agents, all the rest seems just kind of, well, it's classes and functions and sort of software design patterns. And I liken it to the mouse that I've got here. If I turn it 180 degrees, it's a bit odd how to do it. Some people get to it very quickly, but it's still the same movements of left, right, up and down, but it's kind of in a foreign way. And this is where I think AI agents took me a while to get to grips with, because it was like the control got transferred. It was like I was doing everything in 180 degrees difference. And so I think there are three areas concerning agentic AI. Firstly, when we're used to having endpoints, we're used to the code being on the server and we go to different routes, you know, add user, delete user, whatever, get products. But actually what we're going to see, it's actually on the client side. We write and we ship it with our data. Secondly, we use natural language. In our case, it's English. So it's very much like writing pseudocode. And thirdly, there's a sense of autonomy that the LLM will direct the flow of the app. So in a sense, we might know how, from say, if we were going from here to Reading, we might know we would end up at Reading, but which route we took, we wouldn't know. And that's what AI agents do. We can define the overall route, but the AI agent will maybe work its own way through it. And for the purpose of the talk, I'm going to use the term function in the mathematical sense, meaning that we put an input, we get an output that can be put into another function. It could be a class, it could be a function. So for example, if we make a request to an LLM with some data, a payload, we'll get a response. We can then pass it into another query with that response, send it to the LLM and get a second response. We can chain it, provided the outputs are in the right format, and we'll mention that later. But essentially, this is a kind of chaining process, and we're used to that in Python. One thing I just like to do before we go into the notebooks and see examples is just to refresh ourselves is what actually happens when we make an API request. If we're not using abstracted layers, what goes on? We're going to be using the request library. But to basically make an API request, we need an endpoint, a place that we go to. And one of the most important things to notice about this particular endpoint is there's only one. So whatever we do, there's only ever one endpoint we go to. We don't have different endpoints to do different things. Obviously, we've got to send our headers and we'll send our API key. The API key just authenticates and authorizes us. We don't send a pre-conversation ID along with the request. It is stateless. So we'll go into the payload later, but we send some data and then we send a post request to the endpoint with the headers, with the payload, and we get back a response. So the key thing here is there's only one endpoint. We send text and we receive text. We're not sending objects or things like that. It's purely text. So really, in a sense, we're used to doing that. And this key, when we understand that actually all we're doing is putting something into a function that sends an API request and gets something back, that is our day-to-day Python. We're used to doing functions and class invocations, etc. Inputs, getting outputs, using that output somewhere else. And the reason why I might labor that point is, for me, I felt AI agents was something totally different. And when I understood that's really what's going on and it's an API request, it demystified a lot of agentic AI. And I thought, well, it's just kind of regular Python, but with some variations because it's using AI in a sense that it has autonomy and it's like a magical program that does whatever we want if we just write a few instructions in natural language, which seems magical. So what I'm going to do now is I'm going to go into the repo. And as I say, I don't want to spend too much time on the actual code. It's to kind of get a grip of what agents are. Because I struggled with what agents were. It took me a long time to actually get the understanding who was doing what. So just to refresh ourselves, there's just one endpoint. It's stateless. It has no history. We may send history in the payload, but it knows nothing about what went on before. So therefore, everything that we need it to know, we have to send every time. So we're going to set up our first sort of example of making a request to an LLM before we move on to kind of actually creating agents. So you can see here, we're just installing our API key. We're selecting our model. And what we're going to do, we're just going to make a little class just for this notebook on making a request. So we can again see that it is just a regular API request. Later on, we're going to use the libraries from OpenAI that abstract all of that for us. But we send the endpoint. We send temperature, which is the degree of creativity from 0 to 2. So when we want to be very generative, we maybe have a higher value. When we want it to be as strict as possible, we have 0. We send some system prompts. We send our headers. Regular Python, that's just basically going to make that call. So if I run everything, I'm going to instantiate a class. I'm setting up the system prompt is setting up the character or the expertise of the agent. It's kind of giving instructions to it about how to answer. And you usually say you are an expert in. If we say that, we'll get a different answer than saying, give me the answer to this. There's just something about an LLM that responds to the way it's approached. So I'm asking a question here, what is an AI agent? And we get a response back. And what we can do is drill down into the content and we get the answer. Now, the whole purpose of this particular notebook is just to show that it's an API call. We send a request. What is an AI agent? We send a post request, as we do many times in Python. We got some text back. We drill down through the object to get the answer. In this particular case, it's this one here. Now, what I'd like to do is we can leave general questions to the end. But I'm the type that if there's something bugging me, I can't move on. So if there's anything that needs to be answered for deeper clarification or explanation, I'll pause now because maybe somebody else has got the same little kind of stuckness. If not, we'll start moving on to building the agent. So are we all comfortable that we know how to make an API request? And as magical as AI might seem, when we're using AI agents, we're just sending text and getting text back from some magical function in the cloud. Yeah? Yeah?
I got confused between, so maybe I think the mic is, yeah, okay. May you go over like in the last cell? I got confused between the system prompt and the what is being written in the what is an AI agent.
Lovely, good question. Now, the reason why we're sort of system prompt and thing, the reason is, and that was my lax for not sort of saying it, is OpenAI was trained on kind of a set of system messages and a set of user messages. It understands that format. So in this particular case, although we merge everything in sending up, it likes to see them separate simply because that's OpenAI. Different models will have different ways they like to be called. So that's a very good question, because we see what is system prompt. And system prompt, if you've seen any of the big agentic libraries, they may call it the background or the story or the character. They'll use that term as one of the attributes in the class. And that's really all it's saying. It's defining who you are. Because remember, what we're saying to the LLM is we're almost giving it a job description. It knows nothing. So we say, we're going to see this shortly. We're going to say, this is who you are. This is what I want you to do. This is the way I want to get it back. So that actually needs, if that's the only question, I'll move on to the second one. That's a good point to bring up, is now we're going to sort of see why we may want to do these things. So in this example, now we're going to start building some agents. So first we're going to add some instructions. Before we've just made a request. What is an AI agent? Now we want it to do stuff. Now we want a kind of special endpoint where we can actually get a good response back. And if we describe what we want with greater clarity and detail, it will respond better. And things like capitals and markdown, all the things you might see if you were given a job description that makes it easier to see what you need to do, help with the LLM. We get better answers. So we import our stuff. We're going to see this time and time again. We can see, for example, if we were wanting to get a joke, this is how we would just do it in our day-to-day Python. We just make a request, a get request in this particular example, to get a joke back. But what if we want to do something a little bit more advanced and get it to do stuff and return something in more detail so we can do further things? What we can do is build up the system message, because we're going to send two messages, the system message in this example and the user message, that we actually want it to actually have a more dynamic endpoint. We're used to using endpoints where we send something and it does a lot of stuff for us and returns a result. But that doesn't exist with the LLMs. They just have one endpoint that reflects back what we kind of ask from it. So we're going to get into the land of prompt engineering, or what they call flow engineering. So we have our system message. Now we're going to go into the world of prompt engineering. And what we do is we just write some English. The prompt engineering, I'm just calling it that as a variable just to show this is all prompt engineering is. I'm saying, okay, I want a joke from the LLM, but I want it to rate it. And if it's 8.5 and above, I want it to come back and tell us, let's publish, if not to retry. So that's what I'm asking of it. And what prompt engineering likes is if we kind of give it an example. In the same way when we're at work, if somebody gives us an example of what they want, it makes it easier. So I'm saying, here is an example of a joke worth publishing. I'm asking it to respond in JSON format. I'm giving it an example. I want the setup. I want the punchline. I want it to return back the rating. And I want it to evaluate whether it should be published or not. That's my endpoint. And I can add some extra things. Sometimes you might add removal backticks. I'm also saying that please ensure jokes are not repeated if we retry. This is our pseudocode. This is our programming. This is the endpoint that's normally on the server in Python. But this is how we do it when we're doing agentic AI. So we add those two up so that the system message contains everything. It doesn't need to be split like that, but it's the character, it's the background, it's an example. How do we want the output? It's all of that, everything we want. Because there's nothing really at the endpoint other than, other than the LLM, the intelligence, the AI. So now my user prompt is tell a light-hearted joke for an audience of Pythonistas. So we send the payload. The role is a system. The content was that system message that had the background and had the code that we wrote in English. And it also has our user prompt. And we will get back an assistant message. And the way we do that with OpenAI is we invoke this endpoint. And when we get the response back, we drill down into the JSON data, and we would get this answer here. Setup, why did the Python programmer break up with their parents? Punchline, because they had too many arguments. Rating, 8.7. Next, it's deemed we should publish it as opposed to retry. Now notice that's in a nice dictionary. So what we can now do, for example, if we're in an app, we might save all that information into a state object somewhere in our central app. We could store it in a state object if we want, but the most important thing is we know what the AI wants to do as its next step. It's determine publish. So at the end of the day, we've got back the next step in the agentic workflow. So that AI agent can send it back to us and we can do something, or it could send it on in via a loop to another AI agent. This is how the control of the program is no longer in our domain. It is in the overall sense, but which way it gets from Brighton to Reading is determined by the AI agent. And this is a key point. Now, these first two notebooks is it to be effectively accurate. This is what AI agents are. It's a post request. And in the second one, we then defined what we would have liked the endpoint to be had it been programmed on the server side. And we asked a question. We used natural language, client side, send up the instructions, send up what we want the arguments, say what the response was. And in this particular case, we wanted it to sort of also not just produce the output, but to say what to do next. Now, this would go to an agent maybe that now goes publishes it to the internet. This is how the AI agents work. Now, it could seem when we hear about AI agents that it's something so complex. But as I said at the beginning, it's an API request in Python. And if we look at the amount of AI in, say, this notebook, it's one or two lines. All the rest is just standard Python, like we're going to a weather API. And then based on the temperature, we would do something different. Now, does that seem clear enough? And remember, my suggestion is it might not click while we're here. That's why we have the notebook. You can go through it, because I found it a little bit, took me a few iterations to understand who's doing what and why does it seem to work. It does seem a little bit magical that all we've had to do is write some English. And we've got a powerful endpoint. If we had to make that ourselves and extract the information from any request and do something, that's a task. Any questions or clarification?
Was there a condition? Was there a condition in there or something that said if the rating of a particular response was a particular value, publish or not?
Yeah, I mean, this example, it wasn't actually a condition. We said that the LLM rate it, and if it is above 8.5, let us know. We could split this up, but basically I'm saying make a determination, should we publish or not? But also we could rate it, and we could take that rating and do something else. But actually, this is one of the tricky things I found is, well, where's this stuff being done? You know, we're asking it to do all these things. It's the magic of the LLM that we send it up and it just seems to know what to do. So all we've asked is make a joke, rate that joke yourself, tell us what you think the rating is. And if it's greater than 8.5 and you think it's suitable, I think actually I removed that, but say if it's suitable, a few other conditions, tell us whether to publish or to retry. Now, where is all that happening and how does it know how to do all of that? Well, that's the magic of LLMs. But how we use it is just this. And we'll see further examples of things we can just ask it to do that would, if we were writing the Python code ourselves, would be a meaty task. So that's a good question, because yes, I mean, it's kind of like where? I mean, we could change that. A joke is worth a penny for joke or above, and suitable. I think I had this before, suitable to be published. So that's a bit more of like a qualitative. If I do that, and if I run all, Working through, run. Still the same answer. Yeah, so it's come back with the same joke. Sorry, let's come back with a different joke. Because light attracts bugs. It's not, so can you see it came back with a different answer? Now, this is, come back up here while we're on that. So yeah, that was, we come back down. I'm going to look at temperature. I haven't put temperature here, but it's 1. So every time we run it, we're going to get a different answer because we've given it a bit of freedom. What if we'd actually said no freedom at all, temperature 0? Don't be creative at all. It would probably come back with the same answer, but it is not deterministic. And this is one of the big questions that people sort of ask about AI agents. And the big problem with AI agents is they can hallucinate. If they didn't, the AI agents would have taken off because it'd be nice and predictable. But actually, mathematically, it is not fully deterministic. It's not the same answer every time, although it could well be. But it isn't guaranteed. For example, yeah.
Based on what data or on what decision did the AI rate the joke out of 10? Because I think every rating is going to be above 8.5.
It is because it likes its jokes. So what we could do is actually a joke worthy of polish. A joke worthy of polish is a joke that has no offensive. That is, let's just see. A joke is what has nothing offensive, because that might be throwing a and has nothing offensive and is suitable to being published. So that's something very qualitative. Is that? So let's run that. Let's remember what the joke. These are good questions because actually, just these first few files, if one really understands it, the rest is sort of regular Python, to be honest. So tell a light-hearted joke for and what was the joke we got back? I think it was about bugs. Why do you put them punchline? Because light attracts bugs. Okay, so let's just see if we do that. And if we run all. It's still giving us a rating because I think we asked for a rating. Let's just check, is that correct? Set up. Yeah, it's given us because we actually asked it for a rating. See, now this is good because actually we're seeing how the prompt engineering is working. So if we come back up here, where is the prompt? We've asked it to give us a rating. So let's take that out. And let's run that again. And if we go to the bottom where we can just see everything. Okay, it's rating. Yeah, I'm sort of changing too much code. Let's do that. So notice now the output's different. So we've changed our endpoint. We've created, if we're doing an API request, we'll be sending information. We're changing the output we're getting back just by taking out that line. And the part of this that I'm emphasizing is this next part. What do we do next? Well, it's telling us what to do next. We might implement that in our code, or that may be automatically be passed on to something else, to another agent that knows that and then does its own thing. It might be a reviewer. Because you sometimes see in agentic workflows, somebody writes an article, we have another agent that's a reviewer, an expert reviewer. It would pass it on, then the expert reviewer would take that content, magically maybe decide whether it should be published or not, or whether it needs editing, pass it on somewhere else. This is the agentic workflow. But if you see what we're doing, we're sending an API request, send text, get back something like we do in Python, use that output in some way. So let's make something useful that, shall we say we have a website and we want to kind of make it a bit AI-ish. And the usual thing is like a sort of chatbot where we can ask in natural language. Well, how would we change that? So we can add extra information because the model we're using doesn't know about our business. It may have picked something up in training, but it doesn't really have our day-to-day knowledge. we would like to pass the information about our business that people in the chatbot could ask questions. And in this particular example, I'm calling it the FAQ model. We're basically going to give it, it's almost the same. We're just going to give it a list of facts. If we scroll through, it's the same. Admittedly, we're just making some messages here. We have a system message. You are a helpful assistant for a shoe store. If a user asks a question, please be as helpful as possible and use courteous in a courteous and professional manner. You're provided with the following facts to help you. Please be verbose and suggestive. So straight away, we're changing the nature of what the output's going to be. And all I'm doing here is adding in a list of facts. Now, this could have been drawn from a database. This could have been from some search form. But essentially, this is what we hear of RAG, retrieval augmented generation. We're retrieving something from somewhere. In this case, I've hard-coded it. We augment the query we send up, and it generates something for us. It doesn't have to be vector databases and all of that semantic search. It's just adding information. Because up till now, we didn't send any information. It knows nothing about our shop. We're open from Monday to Friday. We're located 123 Main. We specialize in red shoes, but have all colors. What is our VAT rate? We only accept card payments. So in the same way, we add all of that to our system message to send up. Now that's our endpoint. That's what we would normally kind of be programming on the server side. And what I'm going to do here is basically just use Gradio as a little chatbot interface to test it. And I've made a question for myself here. Where did I put it? Let's run it all. I've got it here in the notes, Gradio inputs. I'm interested in green belts, probably coming Sunday, and we'll have cash. Is this okay? Now you can see it streaming away. Thank you for your inquiry. I appreciate your interest. It's quite verbose and suggestive. I'd like to inform you that our store only specializes in shoes. We do not carry belts or other accessories. We'd love to assist you. We don't do cash. We're open Monday to Friday. If you need further help, very verbose. That's a little chatbot that's been quite easy to implement. It's sort of standard code. Now, what information we put in could be more complex. But suddenly now, if you're doing a site for a client and they want, we've got to have AI, we've got to have AI, you could put something like this in, a few spinning circles, and straight away it's an AI-based, AI-powered app. So the next one, I don't think, did I mention that I go to CodeBar as a coach? Yes, good. This actually came up. A student asked me, asked them what they wanted to do, and they said, I want to get a job in AI and Python. And I said, well, do you have an AI department in your company? And they said, no. And I said, what do you do? And they said, oh, it's insurance. I run the reports that people want. I'm the person they go to to know which report to run. I said, that's brilliant. I said, you can make an AI version of yourself. And he said, but then I'd be out of a job. I said, yes, but you'd be heading the AI department, because if you can suddenly do something like that. So this is exactly the same variation. But what I've done is to show how we can do routing, because we've done one way. We've seen what you're going to notice with all these different examples is they seem to be much of the same, but just in a slightly different way. And that's just it, because it's just an API request that comes back that we do something with it. The magic is in the API, but that is the whole process. So whether we call it routing or tool or function calling, it's kind of the same. So this particular example, it's the same code. What I've done is kind of set up a system message that you're a very good report selection agent. You're very good at returning the best report to answer users' question. And I'm giving an example. If a user wants a joke, you reply with, and I put it in pipe just so that I can extract out more easily. There are different ways to have structured output, but for this example, I'm just showing that we can define it ourselves. And the tool is get joke. That's the kind of report or the function we want to do next. Because we're going to see different examples of function calling as we go through. I've given it another example. If they want total sales report, then give them back tool get sales. I put in some markdown boldness because that emphasizes it. The LLM seems to respond well to markdown and caps. And also it prints it out nicely. And then I've just given it very crudely a list of reports. For weather tool, use this. Hotel booking, use the hotel booking. Total sales, use the get sales. It's just an example to show how this would come back to us. And then we could go grab the SQL query, run it, send it in an email or whatever. But we can actually get a way that if we have a form with a lot of structured data, like the drop-down boxes in radio, what if a manager doesn't want to look through a big long list of different types of reports? They don't know what report they want. But if they could use natural language and describe it, the AI, the LLM, could actually work out which one they actually want, know the report, got the input, the arguments, run it, do the rest of the Python code. So it's exactly the same as before, joining it all up, and I'm going to use the Gradio again. And what I've done is pre-made some of these. I've got this. We're planning a trip to Rome. We need a plane as opposed to flight to go there. We may take an auto to Paris as opposed to car, just to show that it's actually can make assumptions and be intelligent. Can you help me? So if I come in here, and in the same in the little bot, if I add it in here, it's come back with the two reports it needs, the get flight and the get car. So straight away, this is called the router pattern. Well, it's not. I mean, it's a big name for it, but it's just getting something back and then doing if else. If get flight, run this report. If get car, run this. Now, this is agentic AI. This is whatever library you go to will be built around this. And I'm going to show some examples later on where there were things that I came across that seemed really advanced. And actually, it was sort of the same, but just in a different type of presentation. So sometimes an agent may need more information than what we supply. So in our tool calling version, what we're going to do is it's going to sort of be the same, but we can get the agent to determine which tool, like we just saw which report, we can specify some tools. Again, it's almost the same as the previous example, but some functions that are in the code that it could call with arguments. So it's also going to show data extraction and tool selection. So let's have a look at that. Now, the first thing that confused me a bit was if it's going to be calling functions, is it calling it on the LLM's box or our box? Because if we're saying run this function with this data, where is it run? It's always run on our own box. And this is from the OpenAI website, that we can see messages going to and fro. And the one that's important is here. The API responds specifying this is the function and this is the data for that function. Run it for me, get me the output, send it to me. So that's the conversation. So if we scroll down, let's have a look at the prompt engineering, because that's where everything happens. All the rest of this is standard code. So I'm saying you're an assistant that is very good at determining what tool to use to solve queries. And I'm calling it tools. I'm saying you've got two tools, a calculator tool that can perform arithmetic operations. If this tool is used, this is how I want you to respond. And notice I'm using markdown, caps to kind of help it. And to send back a dictionary, a JSON object, the tool that it's calling, what to do next, i.e. what function to call. It's going to be the do calculation function, which I'll show you. If, on the other hand, it feels that we've asked for a joke, then to use this, and I'm asking it to be as accurate as possible. And if we go further up, what we will see is my mistake. There isn't an actual function in this particular example. What we're doing is when we're getting it, we're running the code ourselves as opposed to calling a function. So let's work through the book. So we're passing messages to and fro about what we actually want. So coming down here, we said the system message. We've sent our client-side code. This is the programming we're doing in English, in natural language. I'm asking it the question. Now notice again the prompts. It's role and system, role and user. That's how OpenAI likes it. The first question I'm going to ask is, what is 102 plus 3? So when I've run it, it detected that it needs to do the calculator function. Because I said there are two functions, a calculator function or a joke function. We could have lots of different functions, but straight away it's knowing from the English language what it should be doing next. And more importantly, it's extracted out the arguments. It's known that it has to extract out the arguments because we've told it to do that. And what the operation is, addition. So I could call a function, but what I've done here is once I found out what to do next, i.e. what bit of code to run next, I will then run it. If the code is do joke, run this code. If it's do calculation, get out from that dictionary the tool, the arguments, and if it's addition, add the two together. If it's subtraction, subtract them, and to print the answer. So here we've got one agent. The first question we're sending is what's 102 plus 3? Let's ask for something different. And what we've got to remember is if we were doing this in just traditional Python, how would we work out what to do? How much code would it have taken us to do that? Here we see it's just really one API request. So if we come down and actually change it now and actually say, tell me a joke when I'm doing stand up at a Python conference, I've changed what I'm asking for. Let's run it. There we see it knows it's using the joke tool. Do next is do joke. The audience is extracted the Pythonistas. So we know what to do next. We know do joke. We could call a function based on that, but basically it's just an if else. If do joke, if do next, do joke. And there we get the answer. Notice it didn't run the other tool. So if you can really see it, they're all sort of the same. Is it tool calling? Is it routing? Is it sort of just a general API request? It's just sending something off to an API, getting something back and doing something. But the AI is in that endpoint, and we can do magical things by sending instruction sets in natural language, no Python code. If you had a form that had a text box and your user could type in what they wanted, and you had to use regular Python to work out what to do next with that argument, that's a tough job. That's a project. Here it's very straightforward. We're using AI in our regular Python app. And one of the other things that was quite useful is I was watching a YouTube video and it said, make your agents teachable. And I thought, I must have missed something along the line. I mean, that's sort of, and what it really was just extract the information, take it, store it in a database so that next time you come along, you've got more information. It's learned something. So let's see how that would work. Again, it's our usual routine, our API key, setting our model, our system message. What is the job description for our agent? You're a teachability agent. You examine a conversation listed between, and here we're sort of going a little bit more advanced. We can format information using special tags. We don't have to, but it's making it easier because sometimes you'll come across some sort of LLMs that want a very kind of structured approach. You notice that this is like an XML format. We don't have to do that, but we're making it kind of easier for the LLM. This is the kind of our pseudocode. We're saying what the output format should be. I want a JSON format. I want a summary of the information I've sent up. I want also to tell me the number of facts, and I want a list of facts. And I'm just doing this because this makes it clearer for the LLM because it's been trained on this sort of stuff. It recognizes straight away what it can make sense of this. A fact is a dictionary with the following keys, fact and category. I give it examples. In the same way as if we were at work, we'd like some examples of what we're doing. So we'll get back a fact and the category. Charles is a vegan, for example. Personal. Fact. Charles works in Brighton. Category work. And I'm giving an example of what is not a fact. And I'm using a bit of markdown to show that it's important. This is not a fact as it does not refer to a person. London is a city and the capital of England. I'm just giving it some examples. I'm giving an example of number of facts. So in this particular example, I've hard-coded it, but I'm now going to give it some information. And I want it to extract all that information out, give us a dictionary back, And with that dictionary, we could store it in a database. So next time Peter or someone logged in, we've got that information, we can draw it up. We've got that context, which is what we saw in the FAQ model. We need some sort of specific information, not just what the LLM was trained on. There's some information about it. And all I'm saying it to the person is that when you get the information, you're going to be seeing it in this format so you know what data is and what's not. It's not a standard practice. It's just what I'm doing in this example. I don't have to do that. Again, I'm sending up the system information, which was the background of our agent, and the special information like we saw in the FAQ example. I'm going to run it and extract out everything. So if I run all, you can see I've already done it before, but basically it's going to come back with a list of facts. It's extracted. Now that's quite a powerful feature that straight away you can send up a file, send up some information and say, extract the information in this form. And that's part of a data processing pipeline, for example. That's how you see when they talk about AI agents and data pipelines. This is kind of what they're doing. They're looking at a CSV file and they're getting the information out, or they're running a query on something. So I'm getting a list of facts. I'm getting back a number of facts. And I've also asked it to give us a short summary. Now, that can get saved into a database. That's now a teachable agent, which when I first came across it, I thought I'd missed out on something. But actually, it's what I call just regular Python. You're getting information about, you're storing it either locally, in memory, or in a database. So those are the key kind of ones. We've got a few more examples, but they're very much more of the same. What I'd like to really ask now is, does this make sense or does this seem strange? Remember, it's the mouse turned upside down. It takes a little while. It's nothing different to what we've always been done, but there's like a certain shift. Yep. Sorry. Yeah.
One question is regarding that hallucinations and controlled either by temperature or something else. That in fact we need some creativity from AI so that it's creative. It's not just like your calculator. But we when it comes to the data which we get from it, but there should be like zero creativity when it comes to the format of API which we take care of when we call tools, for instance. It shouldn't be creative when it calls these keywords. So is there some controversy? How is it solved?
Very good question. And that's it. That's that temperature. When I think the very first time, and I hadn't been using it, but I think when we did it the first time, there was this thing called self.temperature. The temperature defaults 1, which is in roughly half and half. 0 should mean it's no creativity. Now, for example, towards the end, we'll ask, well, when do we use AI agents? It's all very well doing all of these things, but when would I use them? It's 20 to 8, so I've got about 5 or 10 more minutes that I'll sort of kind of wrap this up, and there'll be a few general questions. I think that's also the right sort of timing. So that's it. So now, for example, you might not want something specific. You might say, a bit like when we did the FAQ, we said be verbose, be suggestive. We did it very creatively. If we change that to be concise in an example, it would have been very short. So that's the so in fact, hallucinations are a feature, some people say, rather than a sort of a bug, because we need that creativity. If it didn't hallucinate, it wouldn't be creative. So temperature is how you say be very exact or be very creative. So yeah, that's it. And I think there was another question. Does that answer the question? Yeah. Yeah.
So maybe my question would sound a little bit imaginary, but from I feel the conclusion of this is that right now we can basically design a whole bunch, a full design system with if and else prompts, with if and else command code plus system plus prompt engineering. So we can is this actually doable?
Well, what you're saying is the title, a bit of AI in regular Python. We just do our regular Python if else's, maybe a state machine, maybe a different design pattern, it's a pub sub. We just do business as usual. It's just we've got the advantage of using AI to do some magical things for us. And that's the same. The router pattern was essentially an if else. We got something back. We said if it was do joke, we write some code for do joke. So yeah, that's it. And that really is it. When you're buying them from scratch, you're thinking, well, There isn't so much to it. When we come to libraries and frameworks, they abstract all of that stuff just to make it easier for us, error checking, structured output, etc. But when one dives in the code, this is it. All of agentic AI program, unless I've missed something and I've studied hard, there's nothing else than this. It's just, and that's why there's like thousands of those agents, because you're doing this, you develop a few kind of classes, some utilities. It looks really good, very easy to use. So you're thinking, other people might want this. Let's publish it. Some people want to pay it. And that's all they really are. And they're very, I mean, when I say that's all they are, that's what they are. They're very good. So that now that when we would go and look at those libraries, we'd really appreciate what they do and we would understand it. It wouldn't be mysterious, which is what it was for me when I thought, well, I don't know what's going on. And as I came through, I thought, is this it? An API request to an LLM in regular Python? That's the title of talk. AI as API in everyday Python apps. And what I'm going to do, because time's getting short, I want to go maybe just to a final example that kind of has a lot of different things. What we want to do is we've got two functions. We want to get the product price of something, and we also want to calculate the total. And we want to pass it from one agent to another. Now, there are two notebooks here. One is the planning, which goes through step by step. We're not going to go through that. What I'm going to do is go through the Py file, but from a high level view so you can see what it is. And what I'd really like to show is there's two functions, one that gets the price of a product, one that actually adds a tax. And I'm going to zoom out so we can see it from a high level view. But where we really come down here, we've got some, as we've seen before, we've got some basically, this is what you do. We've seen all this before, this kind of prompt engineering. What we're going to do is just run it in a loop. And if you notice in all of this, the AI bit, this is the AI bit here. I can hardly find it. It's just this one function. The rest is all regular Python. And what it's going to do, we're going to ask a question, what's the price of a bike? It's going to find the price of the bike. We've programmed it so that actually it will respond back with, I've had a thought, I need to calculate the total, including the VAT. The action I need is to calculate total, and this is the amount of the bike. This is in the example. So let me just scroll that in a bit. So let's go here. So what the prompt engineering is, this is the code. You run in a loop of thought, action, and observation. This is called the react pattern, reasoning and act. Do something, get a response, make a decision. Do we do something again, or do we print an answer? So it's a loop. You think about something, you do an action, you get an observation, and go around the loop. We've got two things, calculate the total, and we've also got get the product price. And here I'm giving some examples, for example, of what would happen if you got a bike, what you should print back. We don't need to go so much into the code, but it's just the instruction set as if you're giving it to a junior dev to say, write some Python code that does this. So we'll respond with thought, what do I need to do? It will say my action is I need to use the get product price function, and it's the bike as the argument. And we will keep doing that. The next time it's going to think, I need to work out the VAT. And when it has an answer, print out the answer. And when we run the code with nice coloring in the terminal, we will see this starting the loop. Thought, I need to find the cost of the laptop. We've asked it, if I just close this down, when we come down at the bottom, the request I've made, is what is the cost of a laptop including VAT? That's the question. So it starts the loop and it thinks, first of all, I've got to find out the laptop price. Notice it's sort of thinking, it's sort of planning. This is why I've called it like the planning example. What's the action? I need to get the product price. That's my function. What's the argument? Laptop. Observation. I've done all of that. It's 300. Because in the code, we said run it. Basically, we did a bit of Python code here that we extract out the information and we just run the functions. That's our Python part. But the LLM is determining what to do. It's planning the process and in what order. Then it thinks, right, now I need to calculate the VAT. So I need to calculate the total, and I know the price of the laptop is 300. It does that. The observation is 360. Now it realizes it's solved the problem. So it says answer found, answer, the price of the laptop including VAT is 360. And if I come back here And if I change the observation, what is the cost of a bike? And I run it again. Starting loop. Cost of the bike is 100. Need to work out the VAT. Answer found. So you can see all those little things coming together. Now, these are very simple, well, very basic examples. Imagine you're building them up. And in libraries, you can have kind of like workflows, a bit like flow charts that are designed as flow charts. And you can make a kind of flow chart and it takes different routes. These are the libraries and the frameworks that are around that really add far more to it. But under the hood, all they can do is send an API request to an LLM and get a response and do something with that response. There's nothing that they've got that's different to what we've got. So I'm wrapping up the code there. We've got about 5 minutes left. And what I'd like to do is actually move back down to, well, to summarize, the industry says there's like 4 patterns. Reflection, that's where we get an output back, write me some code, and we send it to another agent. Your critique, review this code and make refinements, just passing information. We have tool use. We've seen that where it can use a certain function or request that a certain function's called. So we make the data for it and send it to it. Planning, we've just kind of seen. It can look at a problem and think out what it's got to do first. Now, multi-agent collaboration, you've probably heard of like crews and swarms. All they are is just functions talking to each other, maybe having one function that rules them all, a design pattern. That's all it is. In the same way we have many classes and many functions in our apps, we may have a design pattern that one function handles a lot of separate functions. But the reflection pattern that we saw earlier, but we didn't see the notebook, was basically we send some data, get a response back, send it back to another response, another query, to do something with it. Draft me up a nice article, send it to another agent, review it and maybe polish it. What should I add? Send it to another agent that collates it. Just functions. Input, function, output to the next. Now, the question I've been asking myself is when might we use LLMs? When might we use agents? Because sort of thinking, well, it's all very well doing these sort of demos. So I've kind of, for me, it's 3 things. It's processing and input. We've seen that with the FAQ or the router one, where somebody writes in a text box in natural language. We've got to try and decipher the intent and the data and the arguments. That was like in the router example or the FAQ example. To generate output, again, that could be, shall we say, when we were doing the FAQ, we had the facts, but it embellished it and made it more suggestive. That was kind of generative. It was quite creative. We could raise the temperature, or we might say, make me an email, make me a nice marketing brochure, the content. That's when we want to generate output. So we might send up a request and say, this is the plan for the brochure. Please fill in content for all of them. Make it nice and verbose, make it in French, whatever. And then it's to do something within that function. Now, they all seem to overlap a little bit. You do something and you generate text. But I think the extraction example is perhaps an example where we don't necessarily need any output, but we want it to extract information out from something and use it. We're not so much interested in generating anything. We're more interested in extracting and, say, storing it away. So that's where it might be used. Now, the best advice I could probably give anyone is if you've got structured input, don't use sort of LLMs, just use Python, or because you're guaranteed. You're not guaranteed 100% determinism with LLMs. And the example is if you're writing an app that looks at what you've been buying shopping of late and makes your shopping list for you, you might say, oh, brilliant LLM. Would you give it your bank card details and say, off you go and buy food for me? Probably not, because it's not deterministic. So the trap I'm falling into is when I'm building apps, I'm straight thinking, I've got to make it agentic. I've got to use AI. And I'm thinking, well, I've not been using it before. Why have I got to make it agentic? There are good uses, in my opinion, for agentic programming. And then there are very good cases where we don't use it. But my supposition is AI can be a bit of AI in regular Python apps. It's not binary. It's not completely AI or nothing at all. It's not a separate kind of programming paradigm or language. It is Python with an API request to get output to go into and to do something with that. Now, there are many libraries around. If you are starting out, Pydantic AI and Hugging Face, they're simple, more what I call libraries. In fact, they're like simple bricks. They don't build you the whole house. And you can go on from there. Now, Pydantic is very good all about structured output. It's a validation and sort of coercion library. Because we're passing information from one part of the chain to the next, structured output and knowing what we're getting is very important. And Pydantic, having been a basis for practically all the libraries, actually came up with its own AI, I'll call it a library. The same with Hugging Face. They're kind of like small building blocks. But then you can get into Cruise and Swarm's ready-made frameworks, which are very good. Like Llama Index, LangChain, LangGraph, AutoGen, Crew AI, they make it very simple. And because it's quite boilerplate, you can see why no-code solutions exist, because it's a bit like Zapier. It's kind of the same thing each time. You just got to change a few fields and join them together. And finally, Anthropic has a very good article, which I've got the link here, about when and when not to use AI agents. It says, when building applications with LLMs, we recommend finding the simplest solution possible and only increasing complexity when needed. This might mean not building agentic systems at all. Agentic systems often trade latency and cost for better task performance, and you should consider when this trade-off makes sense. When more complexity is warranted, workflows offer predictability and consistency for well-defined tasks, whereas agents are the better options when flexibility and model-driven decision-making are needed at scale. For many applications, however, optimizing single LLM calls with retrieval and in-context example is usually enough. Now, I'm going to end now. If you walk away and it feels slightly there, but you're confused, welcome to the club. It's the mouse that's turned upside down. It's nothing different, but it's just in a different way. And that's why you have the notebook. You can run through it. And I took a few iterations, shall we say, to be able to understand all of this. And if I stand up here and feel like I'm very knowledgeable, it's just been a relentless pursuit of going through it. I'm no different to you. I'm a Pythonista like you. It was just learning a different way of looking at it, because it is a sort of inversion of control. It's autonomy. It's client side for our endpoint. It's natural language, and there's a sense of autonomy. And that's the talk. Unless there are any further sort of general questions, I think we sort of covered it.
So with your PyTest hat on,
Yeah.
what are the complications of non-deterministic output with testing these?
Well, this is the big thing about testing. How do you test? And it's almost like a different sort of paradigm. There are some libraries, especially for like the RAG, retrieval, the chatbot, does it answer that sort of question? With the agents, it's breaking up into small pieces, and it is more tricky. It's all doable. Still the same kind of like the F1 scores you can do and things like that. But what we look for is like completeness, relevancy, accuracy. Are the answers, for example, in the chatbot, are the answers we're getting back? Now, in the case of, shall we say, the flow, you could have your simple agent and just say, if I ask this question, this is where I expect it to go in the flow diagram. It's testing a flow diagram. So it's sort of the same thing. This is the input. This is what I expect the output to be. Remember when we saw in the joke, it came back with next is publish. You might then sort of put that in, or the report, and saying, these are the reports I'm expecting. And PyTest and RAGAS, and there's Giscard. There are various different ones that blend together.
Lovely, thank you.
Cheers. Thank you very much. That was a really good talk. I really enjoyed that. As they are language models, how reliable are they on the output side? So you're telling that language model to output this JSON response to you.
Yeah.
You can't guarantee that it's going to be that. And
Exactly.
it's going to give you that response. So I guess, one, how reliable is it? But two, what can you do to increase that reliability? Is there any tools out there for that?
Very good question. I mean, that's the whole thing, reliability and hallucinations. First thing, the clearer the instructions, the better. Even if it's long with lots of examples, that can improve it. Remember how we gave examples of more and more detail? The same as if you were doing a project and somebody gave you more information, think, oh, I've got a better idea. Temperature zero. it's structured output and actually checking. And that's why things like Pydantic and all the libraries, what you're getting back, you've got to be really clear that it's of the right format to pass on to the next. The answer response, well, it's down to the LLM. It's down to the language model. I mean,
how do they compare the different LLMs to it? Because I was doing a bit of research in this the other day. So OpenAI have got structured outputs now,
yeah,
where you can say, this is my JSON
yes,
in another field, and it'll only give you an answer if it's returning that JSON. But how does that vary across the different LLMs? As there's
they all have now the structured output where you can define it. What we could have done in our by doing it our version is when we did it, use Pydantic, for example, to look at the JSON object, to validate, coerce it, and give the errors. That's why Pydantic is always used by a lot of the libraries, because it's all about the structured output. And Pydantic, that's why they came out with Pydantic AI, because I thought, well, we're doing it for all the libraries. Why do we make our own version? So structured output using Pydantic, analyzing what you're getting back, try, accept. We've done very basic things here. So does that sort of answer? Yeah.
Thank you.
Lovely, thank you. Any other questions? Yes.
Hi. Can we make agents to ask for more inputs? Can we program them to ask more inputs?
Well, yeah. I mean, it's what you put in that system. So if you say, sometimes you see, if you're not sure, they say, don't answer. Don't make, you can, that's another way you can reduce hallucinations. You say, if you don't know, say you don't know. But what you can do is you can do what is so-called is like the human in the loop, because we've just seen a flow. You could actually say to pause so that a human says yes or no. So you could say at this point, ask for input. And that's called human in the loop, where you make a break and it's asked the human, well, type in now your details or something like that, extra information. So it's called human in the loop. Does that answer? Yeah.
Oh, one last one.
It's like a viva voce for my degree. It's lovely.
Sorry, maybe stupid
No.
question. You had the examples, file names numbered from 1 to 6, then 15 and 20. Are the others no?
No, I just no.
Okay, thank you.
Thank you. One thing I've been thinking about with this is if, for example, you had like a chat interface and it needs to be as accurate as possible. And I think that's going to be quite a common use case, in that you would possibly have like a whitelisted bunch of endpoints. And then I guess with this human in the loop thing, which you just mentioned there, if there was one more person that an individual that needs to confirm whether that was the correct thing to actually, it's the right choice to take or not. Is that something you've thought about much at all?
Is that sort of like if you present it to the user and then they click on which of the answers? Is that what you're saying?
Yeah, I guess the language model would make a decision on what's the most accurate response, and then it would be confirmed by the human.
Yeah, that's in fact actually that's again the human in the loop, that you can make a break and prevent it going off and doing sort of stuff like that. So you can make breaks like we do in regular Python. So where we sort of say a form and say next, so are you sure? Yes or no? So yeah, that's human in the loop again, effectively that does that. Does that answer the question? Yeah, good. Yeah, that's a good question. Yeah, that's right. And just to say, this isn't easy stuff. It looks kind of like it should be very straightforward, but I found it's a bit of mind-boggling. So don't feel you're no good if you don't understand it straight away.
Okay, question about stability of the language model, really. I mean, it seems to me there's a bit of a risk here in that you're dependent on the language model behaving in a sort of consistent way across time. Or if they withdraw it and retrain it and it comes back and it starts behaving in a different way. So what sort of measures do you take to sort of guard against that kind of trouble?
That's a sort of very general question. It's maybe out of sort of my remit. You can put in guardrails. I mean, you can. There's another sort of feature that you put in guardrails to protect yourself from certain things, for say going off. That if it goes off, it blocks it, or if the user tries to do stuff. But that's the LLM. We're on the Python side just doing it. I can't speak really for the LLMs. That is the problem. Hallucinations is the big bugbear. If we had no hallucinations or were able to control it so that it never did it, we'd be flying, because it's all deterministic. And we wouldn't need to worry. And that's the main concern, is how do we ensure that it doesn't debit all the money from your bank account because it's hallucinated a request. So that's, yeah.
Thank you. Thank you very much. Big congratulations to Greg. Thank you. It is 8 o'clock, so I'm going to stop us here. But if you have any questions, I'm sure you're around for a little
Yes,
bit,
yes,
and you
yes,
can ask. You can link on with LinkedIn, and we are going to share all of this. You're happy enough? I mean, you've already got access to it, but what I'll do is I'll send it to you. I'll put it on the meetup group, and I'll put it in our Slack channel as well, so you can have access to it.
That's
Yeah, just the link.
Yeah.
Exactly. But that's incredible, isn't it? Like, that's really, really helpful. So thank you so much. Yeah. I've just got a tiny few more things to let you know about. Any announcements in the house? Anybody want to kind of tell us what's going on locally? Oh, nobody wants to announce. The whole thing's gone down. There we go. No, okay. I've got an announcement. Datacove are running Earl, our conference, again this year because it went so well last year. So we're very, very excited that we're putting it on again this year. We have abstracts that are open currently for a few more days. So if you think you have a talk, I'm not looking at all ears because I know some of you are very good and have a lot of things to talk about. We'd love to hear from you. Or if your company would like to be there to have a stand, or if you'd like to sponsor and get your name in all the publicity, we'd love to hear about. We'd love to hear from you, and we'd love to see you there. We know that some people in the room attended last year, and I think they enjoyed it. I hope so, because we certainly did. So yeah, that's happening. That's really big. It's a 3-day conference. It's international. Loads of people come. It's very powerful. It's awesome. So yeah, if you want to host or do a workshop, or there's a lot of opportunities. Our next Pi is in June and then October, and then we've got a special in November where we're going to mix Pi and R. I know, but we're going to do something fun. We'll try and sort something out very cool. So hopefully to see you then next time. Just in case you're a little bit more interested and you want to learn some more Python, in case you're here, I know a lot of you probably are experts and kind of long lifers, but if you are new to Python, or if you're interested in learning some R, Datacove, our company, actually do some training courses. So talk to me about that if you're interested. We're also thinking maybe one of these sessions we might do a proper workshop. So if you've got any ideas about that, come talk to me. And that's it. We're going to go to the pub. So thank you so much for all your time and energy today. There is still a few drinks, a couple of slices of pizza, but that is basically it. Thank you.